Greetings and welcome to another installment of Quant Slob. This is 7th in our foundational series, and this time around we're going to jump into part 1 of our 3-part micro-series on terminology. And just as a heads up, this installment is a heads up, and you'll see what I mean. But before we dive in, let's enjoy some symbols and terms here. Maybe a little intimidating if you're not familiar with some of those, but it goes without saying, of course, that stats, like any other profession or field, has its own terminology and symbology. It's difficult to imagine statisticians and or data scientists collaborating without some common language to express ourselves. Sometimes the same word in one field will mean something different in another. In genetics, for example, differentiate refers to a special type of cellular division and growth. In business, differentiate can mean to have a unique product or service or business model. In math and stats, the word differentiate can mean to find a function slope generating function. Sometimes a scientific term will mean something similar to the way it's used in regular conversation. Consider the word sample. A quality control statistician might sample a selection of electrical components at their job in the morning, then go to lunch and sample the curry rice at a Sri Lankan buffet. In this case, both meanings of the word are strictly speaking different, but they're conceptually fairly similar. And by the way, I've met QC statisticians who look similar to the character in the picture there, so no complaints about the choice of artwork, please. Sometimes, even within the same field, the same word can have two meanings. A medical clinician might use a numeric matrix to model the growth of bone matrix. On occasion, we find the seemingly awkward case where even within the same field, the same word can have two different meanings that seem to contradict one another. The word independent in statistics can be an example of this. In one meaning, independent variables will be those that drive or cause some outcome. In another, independent variables will be mutually unrelated or uncorrelated. This double duty of the same word invites the situation where the independent variables in the first meaning are not independent in the second meaning. Learning a new field requires learning its lingo or parlance. However, learning a new parlance is quite different than learning a new dialect. For example, suppose a native English speaker is learning the Spanish dialect. The word cat translates to gato. The Spanish language student needs to learn that gato means cat in Spanish. However, the student already knows what a cat is. They only need to learn the word for it. Learning parlance, though, requires that the student learn not only the word or phrase, but the thing itself, the meaning. Just to illustrate, consider the capital Greek letter sigma. In math, capital sigma can signify a number of things. One of them is the summation operator. Okay, if that were the end of the story, then absolutely no problem. The symbol is pretty easy to remember. Just like remembering gato means cat in Spanish, but there's more to it, obviously. To understand this particular piece of mathematical parlance, we need to have a lucid understanding of what summation really means. We need to understand the concept or meaning behind the symbol. And heads up, that is no small matter. And I know we just use this one symbol as an example, but if you're interested in summation and learning about it, the Wikipedia page and talk page are really, really good. That's it. That's going to do it. Thank you so very much for tuning in. I really do appreciate it. And don't forget to stay tuned for more Quant Slob.